Okay, so continuing on with our work with classes, this is the second presentation on them. Today we're going to talk about how we make classes work. And you'll recall last time we talked a bit about the theory of object-oriented programming. And in object-oriented systems, everything or nearly everything is an object. And objects in the real world have states and identities, and most of them will have a behavior. Real-life objects that have all three of these possess natural behavior systems properties, or we call them natural behavior systems. Objects in object-oriented programming also possess these three characteristics as well. So, states, identities, and behaviors. So, think of a cat. This is my friend's cat, Ola, from a long time ago. The cat is a natural behavior system. It'll have a name, a unique genetic encoding that makes it up. They'll have states, sleeping, eating, purring, etc. And they can have behaviors such as knocking things over, playing, eating, or cuddling. So how do we make classes work? The general syntax for defining the class that we saw on Monday was class followed by the name of the class, and then giving it a member list in terms of functions and properties or member variables. So like a struct, this will go above main and will have a semicolon. A class member can be either a variable or a function. If it's a variable, you declare like any other variable, but you can't initialize it, at least not just yet. If it's a function, you typically just put the function declaration in the class definition. So in our definition of a patient from the last class, you may notice that some things were public and some were private. Public members are accessible outside the class. That is, anyone can use them. Private members are accessible only inside the class. So, the question is, why go through this rigmarole of making things private? Why not make everything public? And the reason for that is something called encapsulation. You generally want the class to dictate how things are used and modified. So you want the class to actually have control over its own variables and own data. And this prevents you from having things that are known as side effects within the data for the class. So things stay consistent within the class. So for example, if you had a clock, the clock could enforce the fact that you couldn't have an hour greater than 23 in terms of the time if you were using military time, or you couldn't have 35 o'clock. So it would prevent side effects in that way. So we can also represent classes graphically. This is UML that you see on this figure here. That's Unified Modeling Language by Rumbaugh, Jacobson, and Booch. And it can be used to graphically describe the class and its members. So at the top, we have the name. Underneath that, in the purple or lavender, we have the attributes. And then in the gold, we have the operations. So three parts to a class: name, attributes, and operations. So the name is what the class is called. The attributes are the variables, the things that describe the class, and the operations are the functions that it can perform, what it can actually do. When we declare a variable of a class, that's known as instantiating an object of the class. So suppose we define the clock type on the previous slide. We can create objects of the class. So we would say clock type my clock, or clock type your clock, if we were trying to calculate time zone differences to arrange a meeting, and I was located on the mainland and you were located here in Hawaii. So once we declare or instantiate an object, then we can access the members of the class. And we do this through the dot operator the exact same way we did with struct. So for example, we could do myClock.print time. And since that's the function, we need to include any parameters, but this one, it doesn't require any parameters. So we just leave the open parents. Most of C++ built-in operations don't apply to classes. So arithmetic operators can't be used on class objects. We're going to see how to overload them so that they can. Same thing with relational operators. And so we'll figure out how we can actually get those to work with the classes that we defined. There are some built-in operations that are valid for class objects. One is the member access operator, or the dot operator, and the other is assignment. and does exactly what you think it should do for assignment. That is until we get to CS151, then we'll see some cases where it doesn't do exactly what we want it to do. But for now, it works exactly the way you need it to work. Objects can be passed as parameters to functions, and they can be returned as function values, just like structs. As parameters to functions, they can be passed by value or passed by reference. If it's passed by value, then we make a complete independent copy of it. And that can take a long time and a lot of memory if there's a lot of data. So, sometimes we'll see where we pass streams as arguments to functions. And that could take a long time, particularly if we have a big input or output stream. You can avoid this by passing by reference so that it just passes the location, the original, and putting const in front of it so you won't modify anything, so you don't get any side effects. In terms of defining member functions, there are some special member functions, and it's pretty easy to define the functions and the variables. Although the functions, if you don't do them in line, then you have to put them after main and define them using the scope resolution operator so you know which class they belong to. So consider incrementing hours in the clock class. Basically, we want to add 1 to the number of hours. So that'd be like pressing the set button on the clock and then adding 1 hour. We indicate the return type, the class, scope resolution operator. That's the 2 colons, and then the class, and then the name of the function. So here we have void, the name of the class, scope resolution operators, and the name of the function. We're going to add 1 to hour. If the hour is greater than 23, that means we went to 24 hours. That resets hour to 0. This one would be using military time. 2 special functions. We saw this last time with the patient class a little bit. Accessor function access the values of the member variables. Basically, they're called getters. They get the values from the class, and then mutator functions are member functions that modify the values of the member variable. So again, we go through the class's interface to make changes to the class. Some people call these setters since they set values for the class. So next time we'll get into some more details on classes, but that's all for today. Thanks so much for watching.